So 5, it deals with relay logic, which you need to understand, but not as. And then chapter 6 deals with PLC programming or PLC logic. And once we get through this chapter, we can start going to lab. The next time I teach the chapter, I'm going to do numbering systems later in the semester. But chapter 6, PLC programming, is that correct? A second? No, this yours. All I do is just check to see if you made attempts on all of them. So worksheets are not graded for accuracy, they're graded for attempts. So, and then what we do is we give y'all out the key and then see if there's any if you want to go over, and those are the only ones that we work. Okay. Chapter 6, PLC programming. And we're going to have to come up here and get a copy of this thing right here. If I could get a copy of both of them. So what we do is we write programs in a language. And thank goodness we're using high-level languages, and you don't have to deal with machine language anymore. We talked a little bit about that. That's the actual binary language that a computer understands. They understand that most people don't understand that. So what we do is we program in a high-level language, and then when we download it to the PLC, we run it through a translator that translates it to the binary language that the PLC understands. We program in PLCs, we program in 5 different languages, and this has evolved. When the PLC first came out, of course, what they were trying to deal with is trying to move it from the electrical or relay logic over into programmable logic. So what they did is the first language was literally what we call ladder language, which means we learned how to draw ladder diagrams. Over time, this has evolved into several languages that people can program PLC even if they didn't come up through the electrical control relay trade. So 5 languages, and some of them, the application that we're using called RS Logic 500 only supports the last one, which is ladder, and it's by far still the most widely used. The other languages we have is something called function block programming, or FBD. I'm sorry, structured text, function block programming, sequential function chart, and then instruction list. And what they're trying to do is they're trying to make a path where if you didn't come up through the electrical trade and you don't understand relay logic, then you still have the ability to write programs for the PLC. And then your programming application determines how many applications are available for you to actually write the programs in. So RS Logic 500, which is the one we're using, only supports ladder. And if you learn ladder, you'll be okay, because every PLC that I know of supports this language. So this is structured text. This was basically designed for people who came up through computer science and they had learned programming languages like C++ or Pascal. It's basically based on a Pascal programming language. And this is a text-based language, which means you have to learn all the commands that the language understands, and then you got to understand the syntax of the command. Y'all know what the syntax is? S-Y-N-T-A-X. Syntax is the correct way of writing in a language. So when you take your English comp class, not only they're going to grade for content, they're also going to grade for syntax. if you use commas correctly, if you spell correctly, if you use spaces correctly, colons, and all that other kind of stuff. So syntax is the correct way of writing. So in these text-based languages like structured text, not only did you have to know all the commands that the program that the application recognized, you also had to put it in the right syntax. And syntax has to be perfect. Computers don't like incorrect syntax. Okay, does that make sense? But then we would run this through a translator. We have two ways we can translate, and I didn't put this in here. And this will pop up if you ever get into the Step 7 or the TIA portal. When you download a program, it says compile. So compile is a technique we use where they take the entire program written in high-level language and then they translate it into a machine code equivalent. And we call those compilers. It's like the Bible. The Bible's been compiled all kind of times, right? From the original language it was written in. So they take that original Greek and do what? And translate it into English. Even in the United States, we have several translations of the Bible. We have the original King James Version, and then we've got the International Version and all these other versions, but they all have been compiled or translated. Another way we have is what we call interpreted. And interpreted, you actually never generate a machine code program. You translate it one at a time. This is what most of our simulators use. These are programs that you don't actually download into a PLC, but you simulate a PLC. We'll demonstrate one called Logic Pro, which basically it simulates a modular PLC, a 500 series PLC, modular PLC. But you never actually generate a machine code program, but you can play around with it to see if your program would actually work if you actually put it into a real PLC. And a lot of your PLCs come with simulators. So they don't actually generate a true machine language program, and they never go to the actual PLC itself. This is function block diagram. This basically is, if you came up through digital and electronics, this is digital. We have AND gates, we have OR gates, or logic functions, except they use the IEC, the International Electronic Council symbols. These are ISO symbols. Over here, when you take, if you do take digital, we use what they call ANSI signals, which is the American National Standard Institute. So basically, PLCs don't program in the ANSI signals because it's not international. They program in what we call the IEC symbols, but it's still in digital. When you learn about ANDs and ORs and NANDs and NOTs and counters and everything, you'll understand this language. So if you came up through that trade, then you have a way, you have a method of programming a PLC. This is called a sequential function charts. They love these over in Germany. These basically are flow charts. So what you do is you have blocks, and then each block is going to carry out it's going to energize an input or read an input or energize an output, and then what's required to go from block to block. This is what Siemens uses this all the time. And also it's what you prefer, right? You understand. So this is called sequential function chart. This is instruction list. This is very similar to the language that we used to learn called assembly language. What's nice about here, they actually give you the actual logic that this program right here would understand. So these are people that would come up, early stage microprocessors and stuff like that. They would be able to do write programs for PLC. These right here are more powerful because here you can do a lot more stuff with them. But odds are 99% of the things you'll be able to do with ladder diagrams. Okay, everybody okay? Why do they like to program at it, brothers? Do y'all know? It's the TIA portal, but the portal supports all these languages. The version that we have supports, I think, 4 of them. Yeah. Probably this, or this. These are very popular right here. This is probably this function chart. Yeah. It looks Like this? Okay. This is ladder. So this is ladder. So what we do is basically we'll have to learn some symbols, but there are very few symbols. There's a lot less symbols in ladder, PLC ladder, than there is in relay ladder. Unfortunately, when you connect the inputs up to it, you're supposed to use the symbols that you use in PLCs. And we'll be doing that a lot this semester. So we'll start off with them giving you a PLC program, and then you'll develop the relay logic program from that. And then they'll also do the opposite. They'll give you the relay logic, and then you'll develop the PLC from that. And then they'll start giving you what they want the program to do. This is supposed to happen, and this is supposed to happen, and this is supposed to happen. And if it's a sequential function chart, that you could almost take that exact same thing, and program it. It's a really neat language. But this is it, guys. This is pretty much so we learned symbols, and we call each one of these circuits, we call them a rung. And then what we do is we put instructions into this program. But the instructions are represented by a symbol. And these are programs. Are we okay? So this is what we're going to do. We're going to learn some rules of PLC ladder logic programming. We'll look at converting relay logic diagrams to PLC logic diagrams. We'll look at creating logic diagrams when a PLC is offline, which offline we'll talk about the different modes. We have different modes we put our application in, and then we have different modes we put our PLC in. That makes sense. So when it says when the PLC is in the offline mode, this is not exactly true. This is the application that's in the offline mode. So anytime we create a program or anytime we modify a program, we have to bring the application in the offline mode. Some of your newer PLCs allow you to actually update and modify. It's really neat, where you set up a dummy rung, and it keeps the original rung. So if your dummy rung if your rung you inserted don't work, you can always do what? Go back to the original. So a lot of your newer PLCs support online editing or applications. The RxLogic 500 though, you have to bring the application offline. Download, this is gets people confused. What we're dealing with on PLCs is we're dealing with two computers, and the PLC thinks it's the boss. So download is what we do when we send information from our computer to the PLC. Upload is when we take information from the PLC and bring it into the computer. See, I almost made a mistake. We'll talk about using a force instruction, about printing the program, and save open ladder diagram projects, and that's pretty easy to do. So to create a relay logic program, of course, this is a very simple relay logic program. We're using two normally open, even though they've got the symbol. I don't like to draw normally open push buttons, so that's the symbol for a push button, and it's a symbol for what we call a spring-loaded push button. Y'all understand those? What does that mean? So it should be drawn like this. And then, of course, we got two symbols. And then we have a symbol for a normally open limit switch. And then we got the symbol for a relay coil. And this would be a motor control. And they've given the relay coil the name M1. They've given this the name switch 1. They're giving this name switch 2. And they're giving this the name LS1 for limit switch 1. So what they've done is they've gave each one of these devices names, right? Are we okay? Each circuit, and the book keeps getting this wrong. The book does not understand the difference between what a rung is. Anybody know what a rung is in ladder logic? It's a circuit. A rung is a circuit. drawn between what we call L1 and L2. And it could either be a single load series circuit or it could be a multi-load parallel circuit. Okay. And the book says you can only have one load per rung, but that's not true. We can have multiple loads per rung. It's just that they got to be in what we call a different line. So we'll define what a line is and a rung is. So these rules that I've given you out, these are the revised rules that basically more precisely match what we learned in motor controls. So everybody okay here? So these lines are drawn and normally closed, by the way. This would be the actual normally closed momentary contact push button. We took two connection dots and then we draw the actual connection on the bottom. So normally open, they should have a space there. So if you look real close in your book, you can see a space, but usually we don't. We like to define that a little bit more. So this is a rung. This is a series. It got one load, and then and if this was relay logic, we wouldn't do that either. PLCs do that, but relay logic, we would come over here and put dots right here. If you don't have dots, it means what? It's not connected. Yeah. So in drawings, when we draw these things, these relay logic diagrams, every time you have a connection, you're supposed to put a dot. Everybody okay? PLC programs don't put the dots up. So here's our rules. These are revised rules. What'll happen if you don't follow rule number 1, you will get an error when you try to compile it. And you can't compile it until you do what? Until you fix it or correct the error. When RS Logic 500 input instructions must be placed between L1. So basically what we do is we generically refer to this line over here as L1. And we generically call this L2, even though they don't label that on PLCs. And so your circuits are just like electrical circuits. You have to have a plus and a minus for DC. On AC, you have to have a AC and a common or a neutral, right? You understand? So what we're going to do is we're going to draw these circuits between L1 and L2. Are we okay? So the left vertical rail is what we call L1. The right vertical rail we're going to call power rail. We call that L2. And you can see why it's called a ladder diagram. It looks like a what? It looks similar to a ladder. Okay. So here's my input devices, and here's my load. So input devices go between what? L1 and the load. You'll see that? So input, go ahead. All right. Yeah, okay. Input instructions. These are instructions. These are not actually input devices. These are going to be instructions, right? You understand that? Input instructions must be placed between L1, the left vertical rail, and the rungs load, the right vertical rail. It should be noted that any instruction in RS Logic 500 that automatically pops over to the L1 side is considered an input instruction. Now these, in this class, we're only going to be dealing with contacts. If you take the advanced PLC class, we'll be dealing with compare instructions, math instructions, and all type of instructions. Rule 2, with RS Logic 500, output instructions are placed between the rungs control devices and L2, which is the right rung. Nothing is allowed between the rung output instruction and L2. This rule is not supported. I didn't need to erase that. Y'all don't need to learn about RS Logic 5000. But this will cause an error until you do what? Until you correct it, right? I thought I fixed that. Rule 3, all input and output instructions must be placed horizontally. We don't have to worry about that when we program a PLC. This is done automatically for us. Everybody okay there? Rule 5. This will be an error, and this will cause an error till you correct it. A rungs output instruction must not be placed in series with other output instructions. Multiple rung output instructions can only be placed in parallel in another line. One output instruction per line, one or more output instruction per rung. So what we do is, let me insert one real fast so this rule makes sense. And y'all that's had motor controls, y'all should. So here's my rails, right? We call them, and we're going to call this. You got your number system worksheet? Okay. Right now we'll just use push button. We'll just put a push button there. Well, I could come over here and do this. And right now we'll just call this rung 1. And then I could drop down and do this. And then I could drop down and do this. Well, each one of these would be considered a line. So that would be a line, this would be a line, and this would be a line. So basically a rung is going to consist of one or more line, right? You understand that? I could come down here and put another control device down here, and this would still be part of the same rung, but the contact is in a different line, right? Does that make sense? So a rung is going to consist of one or more lines. Thank you, Kelly. Here you go. This is the answers. So basically, it's one output per line, but one or more outputs per rung. Does that make sense? Yes. Rule 5, we'll get an error with this. Program flow is from L1 to L2, and we got some pictures that comes up that's in the textbook. We'll look at this. We're just going straight through the rules right now. Rule 6, rung numbers are automatically placed on the left side of each rung line. So the book says rungs must be numbered, but in PLCs this is automatic. You don't number the rungs; they're automatically numbered for you. Rule 7, each input or output device instruction address is entered above each instruction, and this is automatically too. Instruction symbol. This location is predefined by the Ladder Logic PLC programming application. Note, relative to RS Logic 500, once a logical address, this is actually an address, it's not logical, for a bit instruction is entered at the top of the symbol, the bit address will automatically pop down below it. So this is RS Logic 500. This is what we're dealing with. And we'll explain these steps here. There's a little more to it than this, but so here's what we get by default. So automatically I've got a rung, okay? And notice it gave it, and you'll see on the left, what rung number is it? 0. Now what RS Logic does is when I insert, the top rung will always be 0. So when I insert a rung into this, it's going to take 0, and then the end rung will take the number 1. Okay. So we'll talk. Here's our palette of instructions across the top. What I'm going to do is just highlight this and then drag a new rung down. Now notice it automatically took the what? The 0, and then the end jumped to 1. So the top rung on RS Logic 500 will always be rung 0. And if you see all the E's up there, that means there's a problem with this rung. And what's the problem? Well, nothing on it. Don't have any loads, don't have any inputs, don't have any outputs. Well, what we will do, it will bring we'll bring a instruction down, and this is a instruction we'll talk about later on. And automatically at the top, it's got a question mark, and you'll see it up there. And what it's doing is waiting on for me to tell it what input to use. And we'll look at the address in here. So we'll start off by, I'm going to start off by saying I. What do you think I means? Input. Then we'll put a colon, and then we'll specify where it's at, the slot number. We'll talk about this. And I'm going to put a slash, and then I'm going to put a 0 out there. Now, so 0 is the bit address. So inputs use bits, right? You understand that a bit means, and then I'm going to come up here and enter this. And you can see it input 0, and then automatically the bit number did what? Jump to the bottom. And this is just a feature that's unique to RS Logic 500. Your newer ones, the whole address stays up there. But I still got an error. So what do I need? I need an output instruction. So this is the output instruction. It looks like 2 parentheses symbols, but this is even RS Logic 500 still uses this same symbol for an output. And then I've still got an error. I got to assign it an address. And we'll talk about one. Now I'm going to check to see if there's any errors. So RS Logic 500, once you create a rung, it's going to say errors, and then you got to check it for syntax. So I'm going to come up here. Can y'all see this little thing right here with the check mark by it? And I'm going to click on that, and it says it doesn't have any errors. So every rung has to have an output. Outputs are required. We do have things we call unconditional. They have to happen every time. So anytime I put an input over there, it's going to be conditional, which means certain conditions have to be met before the output is true. There's some situations where we want to, so if I wanted to turn on a light anytime power came on to those 2 rails, then I wouldn't put an input, I would just put it between L1 and L2, right? Every rung has to have an output. Inputs are usually going to be there, but they don't have to be. So if we want to make a rung unconditional, do you understand that term? Then we wouldn't put there. It's a good question. Now, this is a very basic program. So this one, most of your newer ones, the error will clear up as soon as you make the rung correct. With RS Logic 500, you have to ask if it's correct, right? Y'all see what I'm saying up there? This one checks the rung. This one checks the project. And right now we've only got one file in this project, so both these would be interchangeable. So in this class, it would be, you can use either one of them. The little computer with the check mark, or the little note with the check mark up there, would verify if the rung has the right syntax. It don't mean the rung is correct. It just means it's in the right syntax, right? Quick way of writing that rung. So if you wanted to use input 3, you use input 0, the syntax would be right, you understand that, but you used the wrong input or you used the wrong output. So that don't mean the rung's right, it just means it's got the right syntax. So hopefully that explains this rule right here. This is we have to give these instructions, we have to give them what we call an address. So every instruction has to have an address, except for the end instruction. Are we okay? Yes, so. And we'll look at the addressing scheme for RSLogic 500 in a minute. Rule 7A, I've added this. This is definitely not in the book. Each instruction, each input and output instruction should be assigned a symbol name. In new PLC programming applications, these are called tags and are required. In RSLogic 500s, these tags or these symbol names are optional, but we're going to require that you use them, just so you'll be used to doing what when you move into a newer application, that you'll understand that. So let's go back to our program that we're working on. I'm going to insert another rung. I'm going to highlight this. I'm going to pull another rung down. And by the way, see the X go green? That means that's where you're going to put it at. And then I'm going to pull another one down. And I'm going to give it another address, input :0/1. When I hit enter, this box pops up. Unfortunately, so the top box is for comments. So if you ever got into a PLC program where the programmer didn't tell you what each rung did and how things were supposed to work, then that means you got to figure it out by yourself. So you love these guys to use comments. So every PLC language that I've ever programmed in application gives you the ability to add comments to a rung. Then what we have is we have what now are called tags and called symbols. So I'm going to come down here and give it comments. So this is a comment. So notice it appears yellow above the device. You'll see that? And then what I'm going to do is I'm going to come up here and assign this thing a symbol. I've already entered it, so I'm going to have to do it a different way, but we'll show you that. So once we assign it a symbol, then it shows up in what? Green. Okay. Now, symbol name is really neat because once we assign a symbol, I'm going to assign this a symbol 0/1. When you hit enter, you got two options. You can write a comment. So the comment's on the top. And then we can assign a symbol. And you can use lowercase here. Your symbols will always pop up in uppercase. So that's the way we normally assign a symbol, or we can use a symbol table. Now, once I've assigned a symbol, then what we can do is if we need to reuse it, we can use the symbol instead of the name. So what we're going to do is every one of our instructions, we're going to assign symbols. And that'll just get you ready for newer PLC applications that require tags. So tags, if you read about tags in your newer PLC language, those are the same as these guys call symbols. Everybody okay? Does this make sense? So if I wanted to come down here and wanted to put a contact that's controlled by that simulated relay, I'm going to come up here and I'm going to just type in run. And what it'll do is it'll automatically assign it to that address right there. So what's nice about symbols is now instead of using addresses, you're using names. And names are a lot easier to deal with than actually addresses. See, it gave it the same address, 0:01, 0:01. But here I didn't type in the address, I typed in the what? Name, yeah. We okay? No errors. By the way, I need to put an error in here on purpose so you can see what happens. So let's come up here and delete the coil. and then we're going to check it for errors. It says I got an error. Well, what it does is it falls down here. Y'all can see this down at the bottom. It says rung 1. There's rung 1. Output missing on rung. So this is nice to know. So if you do have an error that when you try to check it, check the syntax, if you got any errors that won't clear, it's going to give you down, this box is going to pop up on the bottom that tells you what rung it's in, and it's all going to try to tell you what that error is, right? Everybody okay? So each input and output instruction should be assigned a symbol name in UPLC programming applications. These are called tags and are required. Once a symbol name has been assigned, the name can be used to repeat the assigned address. So it makes it a lot easier. If you signed up for the PLC2 class, PLC3 class, we call it PLCs and automated systems. We'll set up the tag table before we even start programming. Rule 8, optional comments should be added to each instruction symbol and rung. Y'all saw how to do that, right? Okay. User defined, not automatic, RS Logic 5 optional instruction symbols, tags should be given a name that relates to the instructions function in the address. So what we're going to do is they're going to already give you the symbols. So what I want you to do in this class is use the same symbol that they do on the diagram that you're wiring up, right? I mean, you're programming. Rule 10, input output contact instructions address can be used multiple times within contact within the PLC program. Output addresses should only be used once. Everybody understand that? And like I said, we're going to show y'all some pictures here in a minute. Rule 1. Everybody okay? Their input instructions are placed between L1 and the rungs outputs. Output instructions are placed between the rungs, between L1, on L1 and then the inputs. Everybody okay? All rungs require at least one output instructions. Input instructions are normally used but not required, and that was a question that came up. And this is automatic. 5 output instructions cannot be placed in series with other instructions. Everybody okay? Other output instructions. Y'all understand that? Program execution flow must be from right to left. So notice they've got a problem here. So they put this thing right here, which technically we cannot do in PLCs, by the way. Yes, we could. I'll have to show you how to do this. They're showing the complete the complete address, and we'll explain every part of that address. Rung zeros on the top. But here, notice what happens when these. If this contact right here was closed, and then this contact closed, then the signal flow would actually go back toward what? Would actually go back toward L1. So we want to avoid that, right? Rung numbers are placed on the L2 side, but that's automatic. We don't have to worry about it. By the way, in the Siemens programming, they're called networks. The rungs are called networks. So. I don't understand this one. Oh, it must be address. So somehow I've lost one of my addresses. So this is pretty much well automatic. So right now on this one, if you don't assign it until you assign an address, you'll get a little question mark up there asking you to put something in there, right? And we'll talk about the address and syntax in a minute. Y'all got the thing there. So rule 7, and we've already looked at this. So symbols. We got 2 ways we can do it. I'll show y'all both ways. And once you've assigned, symbol names are unique. It's just like your contact list. So your contact list consists of how many of you know all the phone numbers of everybody in your contact list? Hard to keep up with, right? So what do? You assign them to a what? A name. How many times can you use the same name? Once. You have to come up with a different method, right? And that's exactly the same with symbols. Once you assign a symbol name, you can't reuse it for another device. You can use it for something that's controlled by that symbol, but you can't use it for another completely new, another device. Everybody understand that? So your contact list and symbols are very, so you're starting to deal with a lot of addresses. And we'll show you all some PLC programs for the actual manufacturing line over there. These things are about 90 runs long. And if you was trying to use addresses, it becomes very complicated. But if you assign an address a name, it's a lot easier to remember names than it is what? Addresses themselves. And that's the power of using symbols. But new PLCs don't call them symbols, they call them what? Tags. So RSLogic 500 is tag-based. Step 7, which is still part of the TIA. What they did, what Siemens has done is we used to have different applications that did every little thing. So if I wanted to add an HMI panel to this computer right here, I would have to have an application that does it. Well, what they do with the TIA portal, they call it Total Integrated Automation, is they've included all these packages into one. So if I wanted to put an HMI panel, I don't have to have a special application. It's part of the TIA portal. Programming is still S7, the OS7. If you learn S7, the programming language, and the semantics S7, then you would fall right into the TIA portal. They just add all this other stuff for you, plus setting up the communication. So we'll look at the number of applications that's just required on RSLogic 500 to set up the communication between the computer and the PLC. We'll need 3. Well, on the TIA portal, all of them are embedded into one application, which is really neat. So it makes setting up the PLC. So these are symbols. In yellow, these are comments, and that's up here. So in this class, RSLogic 500 symbols are optional, but in this class, they're going to be required. So now when you look at your drawing, it's got all these symbol names, these names up above them. If you give them the same name, it's going to be a lot easier for me to see how it works. Rule 8, comments are automatically placed above the rung or IO instruction. So these are optional, guys. Comments are optional. But comments make what? Makes it easier for you to come back and understand. I've been in a situation where I've written programs and I come back the next year and I'm trying to figure out, well, Rich, what did you do that for? Because I didn't put any what in the what. Comments and say this rung does this rung does this, and the ones we have for the Festo line over there are in both English and German. So these are comments. In fact, this is out of that. The F start flag is set if the initial position of the start button on the control panel or the start button on the remote is pressed. The F start flag is reset in switch position manual. So if you went over there and look at the line, we got manual, we got automatic, and we got reset. So this tells us exactly what's going on with this guy right here. They're calling F start. Exactly what's going to go on with this right here. So I know what's going. So I know what the rung does, right? I know that this symbol, this one was pretty easy to figure out, is the E stop button. This symbol right here is in the cycle. This is switch S3. That needs to be a little more defined, but that's what we got. So this is a part of one of the ladders that run the Festo line over there. And of course, this is an input instruction we'll introduce. We'll use these in PLC 2. By the way, in RS Logic 5000 still does this, is when we put these down drops or these parallel connections, it does these guys right here. Now all of this right here is still L1. It's just that's just the way that Allen-Bradley does it, because all of these are connected right here. So this is still L1 because it's all connected to one common spot. And this is the way Allen-Bradley does their down drops. Siemens don't do it that way, but I prefer the way S7 does it. And I'll show y'all the difference and show y'all, once you learn how to use this one, you'll fall right into other programming languages. I mean, other programming applications. RS Logic 500, a symbol is an optional logical text address assigned to an output or input or output instruction's physical address. Once a symbol has been assigned, the symbol name can be used instead of the physical address. In Euro PLC applications, these are called what? Tags. So they give you the ability to set up your tag table before you even start a program, which is really neat. We can set up a symbol table here before we even start a program. And then after that, I'm dealing with names instead of addresses, right? Starting a new PLC program, if not already accomplished, we have to set up the communication with the PLC. Then we have to start a new project. We have to select the model. So I got that spelled wrong. Model of the CPU being programmed. We need to, once we do that, we'll configure the I/O and then we'll start programming. So number one, we have different methods we can communicate with these PLCs. The 1000, we got MicroLogic 1000. These are fixed PLCs. I think I passed that around for you in a little briefcase. And then the 1100 is what I call a hybrid PLC. It's a fixed PLC, but it can be expanded. So the 1100 supports a communication protocol called DX485, and then it also supports what we technically call Ethernet IP. Siemens calls it Profinet. So those are basically exactly the same thing. The 1100, the 1000 only supports the DH485. But you still have to do the configuration, so we're going to show y'all how to do that. And all our PLCs are set up. All I'm going to do is just take y'all through the steps. So I'm going to go down to the lab. All ours are already configured to communicate with the PLC, so it's just going to be a process of just opening up the programming application and then starting. And RS Logic 500 does something a little weird. We'll have to show y'all that. So first of all, we're going to have to come up and assign addresses, and we'll talk about that in a minute and show y'all exactly what's going on. Connect input devices to the PLC and create a ladder logic diagram. Are we okay? So what we got is when we're up here, we got several options. So this is a PLC application. So right now I got a PLC up here, but I can't download the program because I haven't set up the communication. What you got to understand is that you can write a program on, if you got the application, you can write it anywhere. You don't have to have a PLC. But sooner or later, you're going to have to connect it to a PLC to do what? To download it. So what am I missing? Oh, I'm missing the output instruction. So right now we got the programming application. Can y'all see this? It says offline. And offline means this is where you can, when the programming application is offline, this is where you create the PLC program, and this is also where you edit it. So normally when you run the program, if you got your computer connected to it, the computer does not have to be connected to the PLC to run the program. Once you switch the PLC into the run mode, it's running the program. You have to have, if you want to monitor what's going on, then you got to have the PLC hooked up to it. So we'd have to switch this to what we call online. Everybody okay so far? So what we do, let's go ahead and step it all the way through. So right now this guy, so just to set up this PLC's been unplugged, and it don't have a battery in it, so that means it's lost everything. So what I'm going to do is, just to set this up, first of all, we have to set up communication with the PLC. So what I got to do is I got to run an application. So all the applications that are supported are inside the RSLogix folder. And then what I'm going to have to do is I'm going to have to run something called RSLinx. And this is true for new Allen Bradley PLCs. Now, did we talk about a driver in here? What's a driver? Did we talk about that in this class? Yeah, what's a software driver? Well, a specific piece of hardware. So a computer can do, the processor inside that computer can do one thing, and that's run programs. So everything you see going on has to be controlled by a program. So anything, if we got a like a display, so we got a display up here that's working. Well, there has to be a program inside the operating system that runs the what? The display. It's got disk drives. My computer's got a disk drive on it. It's got to have an application or a program inside the operating system that controls the disk drives, right? I've got a mouse up here. It's a USB mouse. Well, there's got to be an application in there that runs that mouse, right? Understand that. These little old applications, these are not applications, these little old modules that run these are called drivers. So a driver is a piece of software that's designed to run a specific piece of hardware. That makes sense. So you see this every once in a while on USB, where you plug one in and it says installing software. What's it doing? It's installing the driver. It used to say driver, but a lot of people didn't know what that meant. But it says installing software, and then it pops up and says your device is ready to use. So an operating system is a set of programs that make the computer operate. So what you're doing, Windows is an operating system, and then it's got a what we call a shell program that allows you to control the operating system. So Windows Explorer is the shell program that allows you to control the operating system. It allows you to launch applications, right? And we call them applications. Why do they call applications? Because they don't have drivers. Applications apply the operating system to perform a specific task. And y'all be talking about apps all the time, right? And that's what they application. So it applies all these drivers that's already in the operating system. So applications have no drivers. It's just saying, okay, I want to send something to the display. Okay, I want to input stuff from my touchpad, and it just loads in the right driver to do that. So what we have to do first is we have to come up here and install the driver. So we have 2 drivers already installed, it looks like it. But over here, configure drivers. These are all the drivers that supported. Good gracious, guys. These are all the drivers that supported by RS Links. So what you have to do, number one, is understand how you connect to the PLC. We're using, I have DH485 loaded, which is this guy right here, and then I have Ethernet. Are we okay? So, but it can't find the PLC. Okay. So what I have to do now is I have to assign an IP address to the PLC. All right. So to do this, I have to use another application inside the Rockwell software called Boot IP DHCP, which is a oh my goodness, guys, guess what? No, the DHCP driver is gone. All programs, RS Logic software, DHCP boot, it's gone. Where can I get it from? I don't know where I can get it from. I'll have to take a USB stick down to the lab. So I'm not going to be able to do this section until we do that. I'll go ahead and take a 10-minute break, and I'll go down there and see if I can get one. Do I have a USB thumb drive? Yes, I do.